Okay.
There.
Wait till everybody joins. All righty. Okay. How we all doing today?
Good.
Pretty good.
It's rainy.
Good.
In
We
case you
all.
want to know, yesterday I made this light for a ceiling fan.
Oh, that's pretty cool.
Wow.
It's just on the table, so that's a lie.
I like it. Miles, are you gonna grow up and start your own design business where you design different cool things that unique things people can buy?
Fans. It'll be fans, but maybe.
That'd be cool.
MIU, yeah, and the Transformer making a cameo.
Yeah, the
Oh,
Transformer
who
one
is
was
he?
I
Huh?
think we're just waiting on
Oh.
Desiree and Alexis, I think.
Wait, yes.
We'll wait another minute.
Pop quiz,
Well, good
Miles. Who is
morning,
this?
most of everybody.
What?
Good
Who is
morning.
this, Miles? I'm testing you.
No, wait, Emma, what are you saying?
Who is this? I'm testing you.
Oh,
Don't ask me because
he's
I
not.
don't know the names
They're
of
not
any.
Optimus Prime. That's for sure.
Yes.
They sure
I
would have
don't-
been helpful for reference with
I don't know
when
the
we were
names of
trying to get the
any
T-Rex.
I have Optimus Prime right here.
I don't know the names of any Transformers besides Bumblebee or Optimus Prime, so I can't answer your question.
Wonderful.
It's like the dark colored ones are evil and the light colored ones are good. It's like Bumblebee's bright yellow, he's good. What was the one that lived in the junkyard? He was like a little dude.
Redgar?
Yeah, he was cool. I like.
I love Redgar. Oh my god, I love him so much. No way. You know who he is?
That's I don't remember Rekgar. I do
That's
remember
so cool.
Transformer from the TV show who looked like a cat. I forgot. I
It's
don't.
looks like a cat. That's probably Cheetor or something.
Yeah, he was
Yeah.
yellowy looking.
No, he wasn't
Yeah.
yellow. He was bluish gray.
Oh,
Oh.
Ravage?
It was from the Robots in Disguise TV show.
I'm talking about like old school.
Oh man, I haven't watched
No,
that.
it wasn't that. It wasn't that. It was a different show.
Oh, we got a couple more people joining. I was gonna wait a minute for Desiree and Alexis. I don't know if they'll.
They're coming. They're at their Spurs vaulting thing this weekend.
Oh, okay.
I don't know
Yeah, I
if
saw
they're
pictures.
gonna be back.
Okay, then we will begin. Let's see.
Lights, camera, action.
All right. So did everybody just miss out on last week when we didn't have class? Were you all crying?
I was crying because I had to
You
do
know, a
the.
little actually.
I was crying because I had to do math. Like I didn't.
Oh,
I understand. I understood the math at one point. Now I don't understand it anymore. And I only got like 2 problems right.
Oh, well, we're going to be going over it today.
Well, two and a quarter because I got one close.
Yay. Okay. Whoop. Other way around.
Oh no.
Oh, yeah. If you have taken my astronomy class, y'all have seen this chart before.
Oh, this is the
So-
blanket theory. Oh, I love this.
All right. For your astrophysicist here, let's go over some basics. Okay.
Basics.
Basics. That's right. The four fundamental forces. Who knows them? That govern the entire natural universe.
Is it,
Gravity.
I don't know, gravity's relevant.
Gravity. All right.
Is it
So
up, down,
we'll
left, right?
And its associated property, meaning what really affects gravity, is going to be mass.
Is
Now,
one
of
of them?
course, we always make this our starting point. So we're going to make this number one. This is where we're going to start with strength. We're going to say gravity is our baseline. Okay. Who can name another fundamental force?
Weak force.
No
weak
more
Oh,
force.
say that again.
The weak force.
The weak force. All right. So we'll put this one here, the weak force.
The strong force. It's another
Normal
one,
force.
I think.
And we can actually see the weak force through color changes. And we'll call it different colors. So gravity is affected by mass, and we talk about massive objects, and that's what we're going to be talking about today. The weak force, where can you find the weak force?
I think like in atoms. I think. I don't
Okay.
know.
Is he correct, everyone?
No, I don't know.
Miss Taylor, am I
Absolutely.
correct?
No, nobody wants to answer? Do we not know the four fundamental forces? All right, so the weak force, and I think you named the strong force, right?
Yes.
Okay, that's going to be a charge. Okay. They are found in quantum mechanics. So those are
I was close enough.
subatomic forces. That's right. So these things are the glue that attracts. This is when we did our nuclear chemistry class. So these are the things that will attract, like quarks, gluons.
Sorry, did you just say you did a nuclear chemistry class?
Yes.
Yep.
Oh man, that sounds wow.
But we'll do it again because it's always everybody's favorite. So we learned about strong force and weak force in that it's it talks about very, very tiny things, right? The quarks. All right. So how much stronger is the strong force and the weak force than gravity?
Very. I think. It is stronger than gravity. I know that.
Maybe the strong force should be stronger than the weak force.
All right. Well, the weak force is 10 to the 33 zeros afterwards, stronger than gravity.
Oh,
And the strong force is 10 to the 38
Oh.
stronger than
Oh
gravity.
no, wait, I was right.
That is 38 zeros. So it's much, much stronger than gravity. All right, so almost is a good guess. It is not one of the four fundamental forces. But we do talk about norms. So what would be the next one? Last force.
Electromagnetic.
Electromagnetic
Ah,
force. Of course it
Levi, you're
is.
smart.
Magnetic force. Okay. And that has to do with electricity, right? Electric charge. And where do you find that? Where is this force located?
Electric motors. Magnets.
Magnets.
Sure.
Oh,
How do
well, not
magnets,
magnets,
how do magnets work?
Ceiling fans. Ceiling fans. They're located in ceiling fans.
Electrons.
Aha, electrons.
Well, I was gonna say that, but I didn't think it was
Alright.
right.
So this force is between electrons, another very, very tiny thing, right? All right, so how much stronger is the electromagnetic force versus gravity?
Weaker.
10 to the 36th or something.
And to the
Bingo, 10 to the
36.
36. So we have three forces that deal with very, very tiny things that are stronger than gravity. In fact, the reason why you're not being sucked to the center of the earth right now is because of electromagnetic force.
Of course.
Reason why you hold your hand out and it doesn't get sucked to the ground is the atoms and electrons in your hand or in your arm, in your cells. They carry an electromagnetic charge. So these things deal with very tiny, tiny distances, very tiny, okay? We're going to be talking about very large distances. So what is the only force that's going to affect us or big, massive things at large
Light.
distances?
Light, because
Gravity.
Oh,
Gravity is going to be the main thing that we're going to be talking about. These things do not affect at those distances, right? These are quantum and particle, subatomic particle forces, okay? They make the world go round and they make the world, but we're going to be talking about gravitational one, okay? That's our key one today. So we're going to talk about very big distances and very large masses. All right, we're going to go back to our original little map here.
I remember this.
So in the quantum world, right, in our particle physics is the strong, and we're going to get the weak force, right? We're up here. In the classic physics, we're going to do gravity. And then, of course, it sort of turns into the general theory of relativity and space-time in our lovely fabric of space-time and how mass affects that. All right. So, of course, the future, we can sort of attempt to mold the two called quantum gravity. That's you guys' job when you got up. But for today, we're just going to focus on the basics. Okay. Here's the basics. It looks very basic, doesn't it, guys? All
Oh,
right,
no.
so basic.
Yeah. So what is this a picture of?
galaxy.
The Milky Way.
Yeah, this is our Milky Way. All right. So we are, let's zoom in. We are right there, right? And I have 26,000 light years away. I think this has been updated to 28 something thousand light years away from the galactic center. But the reason why it looks like it does is because of gravity, right? What is it at the
Gravity.
center of our galaxy? Does anyone know?
A black hole.
Sagittarius
White
A.
hole.
I was going to ask, do you know what it's called? Sagittarius A.
White hole. Wait, what?
That's right. We know.
right in the center.
Oh, well, it's sucking all the stars in. It's getting all the
Yeah.
mass.
Someday
All
we
right.
too will be sucked in.
We can detect these black holes from various different instruments. We have them in space and on the ground using interferometers. All right. We talked about this a little bit. We won't get into much detail today, but essentially this has to do with detecting gravitational waves through space-time. Okay, the fabric of space-time, these gravity waves will make ripples, especially when two black holes collide, and we were actually able to detect it and actually pinpoint where it was coming from. And here is an actual interferometer on, I think this is the one in Texas. There's two in the States, and I think Russia, if I'm mistaken. I'm sorry. It's been a while since I taught that, but this is the one. Oh, is this one in Texas? This one might be in Russia. I can't remember. But at any rate, this is the one that detected the two black holes colliding. So we can detect gravity from very, very, very far away. In fact, light years upon light years away, right?
Were the two black holes the same size?
Oh, say that again.
Were the two black holes the same size? Because naturally, if there was a bigger black hole, it would actually suck in the
I
smaller.
think we're-
They
Yeah,
both
I mean,
collide. They both collide together. They both move toward each other at the same speed.
Oh,
I think.
yeah,
that must mean they're the same mass.
let's see if I can show you guys. I love the pictures. This shows the wonders of gravity so much.
Oh, I have that exact book.
I know, I love this. This is my screensaver here, or my background. I love this because it charts it into, one is light hours, like little squares. So this is light seconds. This is the Earth and the moon. Then we put the Earth and the moon here in our solar system, and each one of these squares is a light hour. And then they put their solar system here, and this is, each square is 5 light years across. Okay, so here is our next door neighbor, which is the Alpha Centauri. And let's see, here's our Milky Way, and this is us in our Milky Way, right? Let's see what else we have. Then over, let me erase this real quick. Then we go over from our Milky Way, and each one of these is 250,000 light years. Okay, so each one of these squares. So we're starting, this is now the Andromeda Galaxy over here we start talking about. We have Ursa Major and Minor. All right, so when you see these things in the sky, it's hard to understand 250,000 light years away, right? For each one of these squares, you have to add that up. But this is all the fabric of space-time, and each one of these is sort of, depending on the mass, sinking into there, making gravitational waves, right? Ripples in gravity. Always love that thing. So the only time out of the 4 forces gravity can overcome all the other 3 is when?
When there's more gravity than other things.
Okay, so gravity depends on mass. Can you think of the most massive, most dense thing in the entire cosmos?
Black holes.
Black hole.
That's right.
Jinx.
They have
So that-
infinite force and infinite gravity.
That's right.
Infinite
This is the
density,
only
actually.
time gravity can then be kind of overtake the strong, weak, and back force. Sorry. That was my-
They don't have infinite mass though.
background. Well,
Well,
okay. Talk about
They
black holes
measured in
today,
solar
but
masses.
I want to say that's when all of physics kind of disappears into the abyss of the black hole, right? Ceases to exist. Of course, will our star become a black hole?
No.
no.
No, it's not
Yes,
massive
in the
enough, right?
future?
Our star will be, it won't become a black hole, but it will.
Dwarf.
How big does it need to be? Like bigger than the sun?
1.4 solar masses.
There you go.
Which is about how big?
Too big to
One,
count.
140% the mass of our sun, I think.
Oh. Okay. Wow.
Hold on just 1 second. Hey, Victor, be quiet, honey. Okay. So we're going to travel back in time. All right. And I know you guys all read about Copernicus, all right? And these are the 2 models back in the day that were proposed.
Who
created
the one on the light?
Oh, they believed it. So that is the
He looks pompous.
geocentric model. Okay, this is the geocentric model. What does that mean?
The Earth
It
is in the
means the
center.
Earth is at the center. Yeah.
Center, right? So we know better. And what is our model called?
It
doesn't match at
all.
That's right, heliocentric. So this is what they originally believed. The Earth was in the center, the sun goes around, and these are what all the planets do. Okay? In fact, you sort of hear that same sort of language today. They talk about Mercury retrograde, and retrograde just means to go backwards. So this is when people literally thought that Mercury stopped and then went backwards.
That's
Right?
Tara.
hilarious.
Miss
Yeah.
Tara.
Yes.
So, you know how Galileo got in trouble with the church for believing that the sun was the center of the solar system and he got locked in his house until he died? So, you know how he got locked in his house until he died? So, it wasn't until like 1993 that the church actually accepted that his model was correct.
Ah, yeah.
1990.
That's what happens when you don't have science.
Yeah.
But
Isn't
yes,
it kind
they're
of
very
obvious?
smart.
Because
So-
only something really big can have things orbiting around it. The Earth is way smaller than the sun. And
Oh, you're right.
That geocentric model is so messy. I don't understand how they even went with it.
I don't know if it was
Well-
1993, it was somewhere around there though.
A lot of
It
this
sounds like they're just building up on their mistakes, trying to find out what they could make
That's
out of
right.
Earth being the center.
So at the time, they wanted a certain conclusion to be true. So then they just asserted that all of what they were seeing fits that conclusion, right? It's not until science came around that they decided, wait a second, no, let's start from scratch, right? Let's think of this a different way and not think about what conclusion we want to be true. So that's a great observation. So they see this in the sky, as they see Mercury going around and stuff like that. It's why we still have the lingo, the sun sets, right? Because the sun doesn't actually set.
The Earth sets around the sun.
Still sort of use that same language when we had the
It technically
geocentric model.
goes under the point of Earth that we can't see it.
That's right. It goes under the horizon. So the Earth is moving. But we use that type of language from back in the day when they thought that we had a geocentric
Isn't
model
the
of
sun moving
universe.
like really slowly?
That's right. Yeah, well, look that up because we haven't talked
Yeah.
about actual rotations yet and how it's moving through. That would be a really cool thing. All right. So as you guys are traveling back in time, there are people called astrologists. Basically, they use astrology instead of astronomy, right? And they believed that this is a long time ago, but they believed that certain planets that were moving around the Earth, right, were affecting people, right? And did in lives and stuff like that, right? So then they had these awesome scientists, right, that you guys read about in your chapter, hopefully, because you'll have a test on it later. And they said, we're going to figure out how much of a force we have. Now we have 4 forces, all right? So which one is the only one that can affect us at very high distances? I mean, to be fair, we do have an electromagnetic force field around us, don't we? Yeah. And the sun tries to break that down constantly with solar wind, right?
Yeah, but isn't it gonna reverse sometime in the future?
It does. You're right. Yes. And we see that in our oceans, actually.
I have a question. What if the whole Milky Way galaxy was orbiting around some other galaxy? Is that possible?
Ooh, it could- Yeah. So let's actually.
What if the whole galaxy is moving?
I love it. It is.
That everything is moving respective to it.
All right.
That would be possible, but the Milky Way is one of the larger galaxies that we know of, so it would have to be a massive
Excuse me.
amount of mass to get the Milky Way to
That
orbit.
probably means we would already see it.
Such as like 5 black holes.
Yeah.
I can
Wow.
tell you guys love astronomy. Me too. All right. So let's talk about the four forces so we can do this calculation. All right. So we know that I'm hearing a reverb. I don't know if somebody changed their microphone or not. Okay. We know that the four forces,
That better.
yeah, I was gonna say I might have to mute you. Nope, I can still hear it. I'm gonna have to mute it, see if it's you, Miles. Okay, yeah, it is. All right, so we have the magnetic force field around us. No, and maybe it's not you. Does anyone hear me? Reverb?
Heard a little bit of it.
I don't.
Cool. I'll turn my noise suppression all the way up.
Okay, it's
I
okay.
don't
You were
hear
muted and it didn't do anything, so it must not be you.
There.
All right, so what's going to affect us out of the four forces is the gravitational force. All right. So let's go ahead and ask our question. So the question is, what is the gravitational force of both the sun and the moon on humans? So I basically picked something that's very close to us, the moon, and then something that's very massive. All right. Both of those things will have an effect on us, but how much of an effect?
I already
The
did
Earth
that.
is keeping us in its orbit, and the sun is pulling on the moon to make tides.
Oh, we're
the
going to
Earth-
talk about that.
The moon
Yes,
is pulling on the sun. Earth is-
exactly. You can. I was going to say that. I'm going to have my next slide is tides because you can talk about gravity without talking about tides. All right. So let's talk about the big thing. So instead of humans, let's talk about the two big things. So Earth. Let's just talk Earth as the mass, right? So did everybody do these calculations?
Yes.
I
Okay.
tried to do them.
Okay, and you did them fantastic. So the force of gravity is going to equal that gravitational constant, right? And you guys learned how that came about, right? In your reading? Oh, that's going to be on the quiz. All right, the gravitational constant, our first mass we can put as Earth, right? The mass of Earth, 5.9. Oh, is it not going to do it? Hold on. Done. Let's see if I can do this. 5 point. Go back. There we go. I'm going to move this over. There we go. Make it smaller. All right. 5.9 times 10 to the 24th. 7.38.
I
guys
think your
still
voice
hear
is echoing because there's
Yeah.
this little warble.
Yeah, I hear something that sounds like a chipmunk squeaking.
Yeah, it's like little.
All right. I'm gonna mute everybody real quick. And then when you come back on, if I hear it again, we'll see what it is. All right. And of course, this is all over your distance between 3.8 times 10 to the 8th. And of course, that is squared. So all you have to do is basically plug in the values for this formula, right? And you find the gravity. All right. So what is the attraction between the moon and the Earth? What did everybody get?
I got, let's see, 1.9 times 10 to the 20.
Okay, everybody can unmute yourself if you want and tell me the answer.
Oh, wait, I'm not muted.
So it's not you that's doing the.
You got my answer.
I got
wasn't muted.
I got 0.278.
Oh, we must have missed a calculation there. Make sure it looks like this
Well,
one.
Dad said my dad helped me with it and yeah. So
Oh,
we
we're
might have
blaming it
got
on Dan.
wrong.
Come on.
All
I
right,
didn't
so
enough time to do it.
it is it is about 1.9. So we're going to go ahead and say we're going to round 2 times 10 to the 20th is the attraction from Earth and the moon. That's pretty large, right? This is the gravitational forces in newtons. Okay. That's how much force we have. All right. So if we were going to do the same thing with the sun and Earth, now who thinks it's going to be more? All right. Let's not write it on the screen. I have to actually write there. Okay. So who thinks it's more or less than the moon attraction?
More.
Less.
Because it's bigger, but it is farther away.
More?
More.
Less.
Less.
Right, seriously, the moon's like a tiny speck compared to the sun.
All right. So we have our 0.6
Well,
to 10 to the negative
The
11.
sun isn't pulling on us, but it is really pulling on like 8 other planets.
Yeah. 10
So
to
I
the
would say it's pretty big.
It's more.
are 5.9 times 10 to the 24, right? All over. Now the distance I actually gathered for the
same.
so this changes because we're in an ellipse pattern, right? So the distance between Earth and Sun changes. However, the number I gave you, I looked up on this day. What is the literal distance from us and the sun? So this does change slightly, not much. And what do we get for the sun and the Earth attraction? And
3.31 times 10 to the 22nd.
did everybody get something similar?
No, I didn't get something similar. 0.263.
Oh no, it's a very big number. Did anybody get anything else? All right, it's about
On the
that.
papers for mine.
So it is a little more, right? All right, so now this has to do with 2 massive objects, right? The more mass you have on top here, right? Although the distance is called an inverse square law, right? Inverse square, okay?
I've heard of that
Mass
a
on
lot.
top is going to make a very big difference, right? We have the mass of the Earth. So when we start to substitute the mass of the Earth for the mass of a human, it's gonna skew these, right? It's gonna make a big, big, big difference. All right, first, before we go, I do want to talk about the tides, because if you talk about gravity and you don't talk about the tides, what are you even doing? Because it's the major effects of gravity. All right.
You're
so
talking about gravity without talking about the tides. That's what you're doing.
That's right. So I'm going to play this. This is one of my favorite astrophysicists. I'm sure you know Neil deGrasse Tyson.
Yeah.
And it's a little. Who else loves Neil deGrasse Tyson?
I only know a little bit about him.
Neil deGrasse Tyson.
Is he a country singer?
No. He's
I
not.
don't know who the heck Neil deGrasse Tyson is.
Levi, teach your sister about Neil deGrasse Tyson.
Yeah, do that. All right. First of all, I don't think he is anything to do with country. He's a scientist, Lola.
That's why he's an
I
astrophysicist.
don't know.
Because we talk about country singers in science class.
You can look up Neil deGrasse Tyson. He has many books. In fact, one of them is Astrophysics for Kids. Really cool book.
I remember that. I read that once.
So we're going to, okay, let's not draw on the screen because we're going to watch okay. So I'm going to play just let's not draw on the screen. Thank you. Okay. So I'm going to play a short video. It's this one's long. I'm only going to play a couple minutes of it because he does use some bad language, but we're not going to get to that part. All right. So let's see what Neil deGrasse Tyson has to say about gravity. Oh, I say that now. You might not be able to hear it. Let's see if Can you hear it?
No.
Nah.
So you can't hear it?
Nope.
No.
You have to share your screen with sound, I think.
Yep. I was like, you know what? I bet do the share sound. All right, let me share it one more time. And then we can play the video with sound, hopefully. There we go. All right, let's see if it works.
From my personal experience,
working.
anything you want to know,
Here we
this
go.
man right here, especially when it comes to science, has the answer. Okay? So,
No, I have an answer. Whether or not it's the answer, that's to be determined.
please, you're ruining what I believe in. Okay?
I want to dismantle your belief
Yes,
system.
exactly. My whole world is crumbling. I need to believe in you, man. All right?
Tides are widely misunderstood.
Okay.
All right, I will say the next thing I say may be mind-blowing to you.
Okay.
Okay, the tide doesn't actually come in and out. What? What happens is there is a bulge of water, two of them on opposite sides of the Earth, caused by the sun and the moon, and Earth turns inside that bulge. So when we say the water rises and falls tidally, what's happening is we are rotating into the bulge and then out of the bulge.
So the bulge is already there.
It's already there.
And all we kind of do is pass through the
Pass
bulge.
through, and the water gets high and it gets low. So we're stuck with language from our own perspective rather than language of what's actually happening. It's simpler that way to say the water goes in and out. It's simpler to say the sun set rather than Earth rotated such that our angle of view on the stationary sun fell below our local horizon.
Right. Yeah, sunset is far more poetic.
Yeah, you go to the sunset tables,
Yeah.
to look this up.
Yeah, because you can't say to a girl, hey, how'd you like to go and watch the angular momentum of the Earth cause the sun to disappear behind a horizon?
Hello, where'd you go? Let's look at just the Earth and the moon for the moment.
Okay.
Okay.
Which
There's
many people think the moon is what causes it.
No, the moon is 2/3 of the tides.
Okay.
Okay. The sun is is 2/3, 3/4. Depends on the distance. The sun has its own tides on the Earth.
Oh, snap.
Wait, in fact, the tides that the moon raises on Earth are the same no matter the phase.
Okay. No matter the phase of the moon, which
Yes.
there are some people believe that when you have a full moon, what you have is a higher tide because you have a fuller moon.
You do have a higher tide.
Oh, snap.
But the tide that the moon raises on the Earth is basically the same no matter its phase.
No matter its phase.
What happens at full moon
Uh-huh.
is that the sun's tides add to the moon's tides precisely.
Oh, snap. We talking about a tide assist from the
A
sun?
tide assist.
Oh!
A tide assist. And so that's why
And that coincides with the full moon.
coincides with the full moon. Because the full moon, you got the moon here,
Right.
Earth, and the sun. Everybody lines up.
That's what it is.
In fact, we have a word for that.
Go ahead.
That has the most number of letters when scripted, is a dip below the line.
Okay.
I know that's a weird record to hold.
Right.
The word is syzygy. So syzygy is when three or more objects come into alignment in, cosmically.
Right.
So you have the moon, the Earth. The moon will have the same tide it would at any time, but
Right.
now it lines up with the sun.
Right.
They add together, you get the highest
tide.
tides at full moon and new moon. So now I ask you, when would you get the lowest tides?
When the sun is not lined up.
Okay. Okay, let me quantify that. So when the sun is at 90 degrees,
Right.
the sun is pulling this
This
way,
way.
and the moon is pulling that way, and the two waves
Right.
basically cancel.
Exactly.
They try to cancel one another, so you have the lowest tide. It's called the neap tide.
The
We have a-
neap?
Neap.
Neap tide.
Neap tide.
See, look at this. It's not the moon. It was the sun all
All the
along.
time. It was the sun all the time.
I see. And you think,
All right, so we calculated this, right? So we calculated that the moon has a pull on the Earth at a force of 2 times 10 to the 20, but the sun has a force on the Earth 3.3 times 10 to the 22. Okay, so the tides are affected by both the sun and the moon, right? And
I didn't
how
know
we're
that.
gonna rotate within them. Yeah, well, good. Now you do. All right. So the question is, what humans, does it affect you at all, guys? So all you have to do is the same exact formula, plug in the same values, except the mass Earth. You're going to put in the human. Okay, and I said it's about 100 pounds, about 45 kilograms. So what is the force of the moon? The gravitational force of the moon on a human?
Miss Tara,
Yeah.
I did the math for these problems. I remember doing it. I don't know where the papers for them are at the
I
moment.
think you did it right if I remember what you submitted.
Okay,
You remember?
thanks.
Is it going to be a lot?
No.
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 All right. So it's actually 0.00151 newtons.
That's what I got.
So I want to kind of show you, here's your spring scale, right? I don't know if anybody has their spring scale next to
I have
them.
one.
I don't have
See
a
if you can pull 0.0015 newtons. You would need a very specific skill to do it. It's basically like it's not even like it's like a whisper. Right? So the answer really is not much. Doesn't have much of an effect at all on humans, right? And well, let's see the sun. Now it does have it is larger. So what's the gravitational attraction of the sun to humans?
I got my spring scale.
It is 0.264.
6.4 newtons. All right, see if you can pull that on your spring scale. Can you pull 0.2 on your spring scale? So I think I can. It's like
It's right here. It's right here. It's right here.
Yeah, it's like it's no more than just like a light touch.
Just under halfway of 0.5.
That's right. Yes. So it does have the sun technically has more of a gravitational effect on humans than it does the moon, okay, or attraction, I should say. But it's very, very minuscule because it all depends on mass, and relative to the Earth, we are very, very, very small.
Oh,
Mom or two others?
Well, when you put it in your phone, it does that.
Oh.
All right, so at any rate, all right, here we go. I'm going to do that, and then that will happen. All right, so this is your challenge. I have a challenge for you guys. All right, here's the challenge. And I'm going to put you guys into breakout groups to figure it out. I am going to preface it with, this is usually like AP or college level
Wow.
question. I don't expect you to get the right answer, but I do want to see your thought process on how you're going to do it. And I'm going to give you some hints. Okay. So here is the Earth and the moon. All right. Let me have my drawing here. We'll do a white one. All right. And you're going to take a spaceship. Here's our spaceship. And we're going to fly it somewhere here. All right. We're going to fly our spaceship.
Oh, let's calculate how far we have to go until the moon's gravity starts pulling us in.
Oh, we do. But
Yeah,
even more.
I watched Space Cowboys the other day.
That's right. I love this question. It's on most standardized tests, colleges, AP exams, stuff like that. Where does the gravitational force between the Earth and the moon equal 0? Okay. So I want you to kind of imagine your spaceship here, and there's a force pulling this way and a force pulling that way, right? So if we say the force of the Earth is going to be our negative direction, right? And our force of the moon will be our positive direction for our spaceship. That's where it's going to. At what point between both of these will the forces cancel out the gravitation and equal net 0?
just should be right in the middle, huh?
Okay, so here's your hint.
Hold on. I can't see the screen. If you were drawing on a screen, I can't see it.
Can everybody see it, or you can't see the screen?
Yeah,
I
I can
can't.
see it.
I can see it.
I
Okay.
can see it.
I can see it.
I have to adjust your screen. All right, so these are the two things. So you only need one equation. I'm just going to tell you that right now, and it's our gravitational force equation. Okay, so G big M little m, or M1 and M2 over R squared. So everybody write the general equation.
Okay.
Your hint is going to be, okay, so the two forces, or the summation, remember learning that force, is going to be the negative force of gravity of Earth plus the positive force of gravity from the moon. Okay. So if we rearrange this equation, okay, this would obviously, this negative number and this positive number, that will be a net zero. So what you're going to be going with is negative G M of Earth, right, equals the moon. Now, R squared is going to be different. R squared is going to be, so you're going to have one gravitational force equal to the other one, okay? The radius is going to be something different, because you can relabel it distance from the Earth to the ship, and this is the distance between the moon and the ship, right? I will give you one more hint and say the distance between the Earth and the ship plus the distance between the moon and the ship is going to equal our total distance. Does everyone agree?
Yeah.
And know that number. That's a number we know. Okay.
Like 238,000 something kilometers.
So you don't have to know the answer. I want to see how you guys work this out. Okay. So this is great algebra. All right. And of course, when you guys are done and you're going to work in teams, you're going to try to figure out how to solve this to equal that. Okay. And what you're solving for is from here to here. What is that? How far is the ship before it equals net zero? Okay. Now this is very difficult. Like high school seniors cannot solve this problem.
Mr. Mike level physics.
So this will be fun. You don't have to get the right answer. But it'll be interesting to see some guesses and reasonings why. And if you could do it mathematically, extra points. All right.
And if you can do it in your head, you get money.
All right, let me see if we do breakout.
No, I calculated it. I did.
Okay.
I knew the distance between the Earth to the moon was 238,000. That's right when I was talking.
All right. We gotta have
Okay, we're back.
time for the Kahoot. So, you know, I had
Can I
to
go
bring her
first? Can I go first?
back. Sure. Yeah. Is it your team
Okay.
that's gonna do?
No, I want because I tried to do the problem personally.
Okay.
So I knew the distance between the Earth and the moon was 238,855 kilometers.
Okay.
And 9.81 divided by 1.635 is 6. So I divided 238,855 kilometers by 6, which is 39,809.16 kilometers. So then I drew 6 different lines on a drawing from the Earth to the moon. And I chose the one that was the second to the last right one.
That's what I
Yeah,
did.
I'll show you the diagram I drew. Wait, let me turn off my background first.
Yeah, what is that, bro?
So far, Miles, but that isn't exactly how a team
Yeah.
works.
This is my drawing.
Okay. Cool.
And I got 159,236 kilometers as my answer.
Okay. Oh, I got a different answer. It's a little.
Okay. 159,236 for miles. Okay, so what did your team get?
We
Um,
got
so- 204,500 and
715.
Yeah, so basically how we got it is we added the area of the moon, not the area, we added the moon's gravitational force to the Earth's gravitational force and divided that by the distance in between the Earth and the moon because it's like a proportionality. And basically, if you made a Venn diagram of both the gravities, like how far it would go, you'd find at the intersected point. And so basically, after we divided it by the Earth's gravity plus the moon's gravity, which was 11.441. We got I don't remember the number. We got some number and we multiplied that by 9.8. We multiplied that by 9.8 because it would be how far away from the Earth. Well, you could also multiply by the moon, just have to subtract it from the real number. And that we got 204,715. Point something, I think.
Interesting. I do because I've heard this twice now. Why is everyone using 9.8, the acceleration due to gravity on Earth?
It's 9.81.
Right. So the G is not that. The big G is the 6.6.
Oh my god.
And then what's the moon's gravity? They were saying like 1.1.
So the 9.8 is definitely the gravitation acceleration due to gravity on Earth for sure. But if you look up in your notes, it also has a different G. Do you guys have your notes next to you?
No.
Yes.
Okay, big G is 6.6 times 10 to the what?
36.
To the 30.
Negative 11.
Negative.
So I love your thinking, and you guys are very. I love your number. You're in the right direction, right?
Miss Tara,
I think we're a little off because of the number. Yes.
how close was I to the answer?
Well, we're gonna
Yeah,
hear
it
from
is.
our second team.
Yeah, if it was like 6.6, I think it's probably closer to Miles's answer.
Maybe. All right. So
I,
let's.
I
hear
didn't
from
use
team-
6.6 either.
Let's hear from team 2. Let's see what they got. Came
Wait, what's the moon's gravitational force?
6.6.
times 10 to the negative 11.
Negative 11.
No, the gravity is 6.6.
Say that again. You broke up.
You are breaking up.
Yeah, I was
They were,
gonna say,
they were in a
is-
car. They were in a car.
Missing
That's
it.
why.
Funnel.
Oh, they're back. They're in a Tesla.
Okay, so let's hear from team 2. What do you guys get? And team 2.
I was off in space the whole time for some reason.
Okay, well,
I do a lot of imagining.
That's not good.
Thinking.
Where's my Jeopardy music?
Wait, I have it on Spotify right here. Somebody let me share
Alright.
sound.
Team 2. Who wants to give it a go? I will say, I don't care about what your answer is. I care about your thinking, right? What you were thinking.
Well, I have no idea.
You were thinking anything?
Where's Levi? Where's everybody else?
Yeah, Levi, where are you at? What'd you get, Levi?
I didn't come up with anything 'cause I didn't know all the variables.
Oh, okay.
Mm-hmm.
All right. So,
None of us took a screenshot. None of us took a screenshot.
Ah, yes. Please show your evidence.
all right. So I will put you guys out of misery. I will show you the answer.
If it's like this big number, I swear.
It is a big number.
No,
All right, and I'll show you how they do it because it's very important. You should all write this down, and it all has to do with algebra. All right, so here's sort of what I gave you. All right, I wrote down a little bit of it. I'm gonna do what? Okay, so here are the two equations. We need the first force of gravity to equal the other force of gravity for a net zero. Okay, we're going to solve. I've changed all the r values, the radiuses, right, to distance from the Earth to the ship, and then also from the ship to the moon. Okay, I've replaced the distance from the ship to the moon with the distance, the total distance from the Earth to the moon minus the Earth and the ship. All right. So basically it's this value minus this value will equal that value. And I've plugged that in right here. Okay.
So simple.
So now it's now it's just algebra, and we're going to cross stuff out. All right. So not sure how much of you guys had algebra, but
I knew we had to cross something out.
right. So what we're going to cross out is, well, there's a negative g on this side. And if you try to, I don't know what that is. Okay. And if you try to do algebraic equations, you know, add it to the other side, it will cancel it out, right? The same thing with this little m here. Subtract it on the other side, that'll cross out. Okay. So we have two things that we have crossed out. The big G and the little m's. All right. So now, okay, Eli, don't know what that is. So I'm gonna say no. I don't know what it is yet. Hold on. All right. So now we have, what we do in algebra is we try to get everything sort of like terms on one side. So what we're going to do is get all the distances on one side. So how do we get this to that side in algebra?
We cross out the same letters. Like you cross out D.
It's technically under the division sign. So we're going to multiply it, right? Like we'd have to multiply this value by itself to go to the other side. So we're going to move this to the other side, and we're going to get the distance, the total distance from the Earth and the moon, minus the distance between the Earth and the ship squared. So we're bringing this whole bit to the other side. And then, of course, we still have this term. So we have the distance between the Earth and the ship left. And then we're going to bring the m's to this side. So we have the m on this side and the m on that side. So,
how big would the answer be? How many digits?
oh, you'll see just a second. All right. So this is the equation we're going to have. All right. So we've got all the distances on one side and we have the masses on the other side. In algebra, oh, sorry. Stop. All right. Miles, I think it's too much. Okay. There we go. So in algebra, how would we get those squares? I don't like the squares. How do we get them to go away?
We cross them out.
How do you cross squares out? You have to do the opposite.
You subtract them because they're the same exponent.
Hold on. Emma, hold on. Hold on. Emma, hold on. How do you take the squares out?
You square root it.
Thank you. You square root it. All right. And of course, if we square root this entire side, it would take out the squares. But what we do to one side, we have to
Must do the other side.
Other side.
But
Okay.
then
So we do have a square root on the other side, which is fine. We have a calculator that can do square roots, but we have these squares out. All right. This is the same, isn't it, guys? So what does negative d sub e ship over d sub e ship equal? What does that equal?
0.
So we have d sub the total Earth and the moon over d this is going to equal 1.
One.
In fact, it's
Zero.
going to
I was
equal
close.
-1.
Definitely.
Okay. So that's
Like,
going to
it's
equal
a very big
-1.
number.
All right. So we're almost there, guys. We want to solve. Okay. We want to solve for this. So how do we bring all these terms to the other side?
Add 1.
Yeah, sure. Let's add 1. All right. So we're going to cross it out. We'll add 1. Cross it out. We'll add 1 to this side. This one, what do you have to do?
Multiply it.
Maybe you should add 1 for you.
You'd have to divide it, right?
Mm.
All right. So unfortunately, if you do that, you get something like a 1 over D sub E ship, right? And we don't like that. So if we want this D sub E, we're going to flip everything. Literally everything. We're flipping everything in order to get this.
1
So
over
you're
1.
right. So we find our answer is going to be equal to
That's
the total distance between the Earth. So if we flip this side, we have to flip this side. So this is also going to flip. The total distance of the Earth and the Moon, which we know, divided by the square root of the mass of the Moon divided by the mass of the Earth plus 1, right? And we can figure that out. We know all those values. Who has a calculator, wants to put those in? This is the distance between the Earth and the Moon divided by the square root of the mass of the Moon divided by the mass of the Earth plus 1. And that, of course, is underneath this little thing.
Distance between Earth and
I
Moon.
should put this in parentheses. Actually, let me make sure you guys can read that better. Plus 1. Okay. That's how we find our neutral net zero point.
What's
This
the
is an equation you would do in 12th grade. Now, all you have to do is put in the values. So who knows the answer?
Not me.
So I gave you the distance between the Earth and the Moon.
5 point? I ain't putting all that. Hold on.
Show you on my Desmos, but if someone has the answer first, please call it out.
I am trying.
Okay.
5.97.
Once I get at least one answer, I will tell you what I got.
10 to the how much? 20. Let's put this in parentheses. What are the sub variables in both of the M's? Oh wait, Moon and Earth. Okay, I'm done.
Okay, what was your answer?
I have not gotten an answer yet.
Oh, okay.
7.34. Okay.
Da, da, da.
34 times 10 to the how much? Okay. Oh, what was that again? Oh, I forgot.
Does everyone remember the values? I will show you them over here.
I did.
Those are our
I'm getting there. I'm getting there. 230. 900. Okay. 200.
Victor, be quiet.
26,489.6.
So close.
Ah.
Okay, so the answer is the distance to reach net zero. I've gotten 2 depending on what numbers I use, but it's somewhere between, oh, that is wrong. It's not 2. It is 346,000, no, 3.4
million.
Yeah. Million,
Wow.
which is
Oh, plus
about
one. Plus
plus
one.
1, which is about 90 to 99, depending on what percent of the way to the moon would be net zero.
Wow.
That's
So
true.
right here.
Moon small.
We were way off. Yes.
I will say this, you were in the correct direction. You know what I mean? You didn't get some weird off, really super small number, right? You were definitely headed in the right direction.
Isn't the moon 1/6 the size of the Earth?
That's right.
Then why isn't it
You did that.
5/6 of the way?
1/6.
Oh, great question. Because of this equation right here. So you can answer your question by doing this math. And if we have those 2 equal to each other, you should find theoretically and mathematically a net zero point. Okay. Now, whether that happens or not is another question. Right? But this is a really cool thought experiment. Where you could maybe find 2 forces canceling out to 0, right? I think you guys did a great job. It was very, very difficult. This is a great example of what you'll be doing in algebra, advanced algebra, stuff like that.
Oh boy.
Yep. Basically, it's a big puzzle. I love algebra because it's like a big puzzle you have to figure out, and you got to rearrange things, and you got to know the rules.
Yeah, you like to torture us.
Yep. All right, who's ready for the Kahoot? Y'all
Me.
have been tortured.
Me, oh my god.
Yeah.
Please.
Are you done
me,
being
okay.
tortured?
Kahoot.
Okay, let's see if I can find it. Let's see. I'm gonna try on my computer first.
I'm predicting it. I'm getting 16th place.
Then
There's
it'll
not
tell
even
you,
16
aim for the
of us.
podium.
I'm getting 4 billion.
I'm
16th place is a
leaving.
reasonable answer for this kind of Kahoot.
Are you on Kahoot, guys?
Give me a second.
Mister is still loading
I
it.
need to get my story straight, my friend.
Oh,
wait,
is it doing that
What's
thing
the
again?
game pin?
Love that she is waiting for me just to press the button. I gotta stop singing.
Okay, let's see if it lets me do it. I remember this time it was host live game. Let's see if it does it.
What's
And
the game
then calm
pin?
down and they go by where bubbles all the time like soda.
What's the game pin?
It's
I can't-
loading.
I can't see the game pin.
It's
Right,
still
hold on,
loading.
this one-
It's loading.
Yeah.
It's loading.
Okay, there we go.
Let me know
Oh, shoot.
when it's here.
It's 424
208.
208.
424 space
224 208. Enter.
424 208. Is that the game pin?
Yes.
Me, I'm a guy. I'm scared.
Get me out of here.
It automatically loaded
It's my arch
boy
nemesis.
and dog.
Toes.
Guys, I'm Elvis.
Wait,
Oh, that's who Toes is. Okay.
Y'all
Lola.
didn't know
Okay.
who I was?
Lola,
I've
are
said
you
it on
Bobby
multiple
Birdie?
occasions.
You were my arch nemesis last round, Toes.
Yeah, I know.
Toes.
I even admitted that.
Who's
I did not hear
Toes?
you over the sound of my screaming.
Who's Toes?
That would be me. Thanks.
Okay. If I am, get me out of here.
Oh my gosh, Miles.
What?
Is
You
that
just
everybody?
lagged out
I think,
really
is
bad.
that everybody?
Yes.
My character is
There should be
fly.
one more person.
How many people are in?
Several.
We have
Stop
10,
Because if it's just minus Mr.
10
there should be one
players
more
in
person.
here, and we have 12 participants.
Oh, there we
Okay,
go.
that's
All right, let's
Oh, we're
begin.
going.
Gravity.
I shall make a prediction. I am going to get last place.
No, Emma's going at last place.
man.
I just told him.
Oh my gosh.
He broke it when he used
It
it.
broke. It just broke.
It just broke.
I just broke. I just told them.
No! No! I misclicked!
Whoa.
Emma, how many Weird Al Yankovic, Emma, how many Weird Al Yankovic
No!
song lyrics do you know?
I was
Probably
trying to.
I met him in a swamp down in Dagobah, where it bubbles all the time like a giant carbonated soda. SODA soda.
What is this?
soda.
I'm
I
in
have
10th
3
place,
points.
61 points behind
But the
Bob.
little one sitting there on a log. I asked him his name and in a raspy voice he said Yoda.
Soda.
IODA Yoda.
Yoda.
Yo. Yeah. I feel that song a lot.
That's
I
the
know that
weirdest,
one.
that's the weirdest picture ever.
Oh, yippee, I got it right.
Who's
In
bobblehead?
third place, I stand right here.
Relativity, gravity is a result of what?
It is the slowing down of time.
He's slowing down this time. Oh, I didn't think I got that right, but apparently I did.
I'm behind Lola.
So best.
No. Yes. Oh wait.
Which
I'm
one's the
speaking
answer?
truth
No,
because
no,
he seems
yes.
the kind of person who would do
Y'all,
that.
the answer is
No.
invisible.
Newton.
Oh, never mind. It was
No.
incorrect.
Oh, yep. Fifth place.
The entire
whole-
leaderboard changed.
No, I'm still up there, number 1.
Ooh. Weight of the world. Calculate the size of cats.
Must calculate.
Cavendish did.
I thought it was Cavendish. Like
He didn't calculate the
Cavendish.
size of cats.
It's
I know that.
Cavendish.
I thought there was like a really fancy food called
He's very
Cavendish.
Cavendish.
Bro has to calculate the size
Oh,
of cats.
shoot.
Can't
Yippee.
Oh,
Fourth place.
I'm 11 points behind Nick's name.
Kepler.
Oh.
He confirmed himself.
Nope. I think I got that
yes, 100%.
John Michelle.
wrong. It was yellow, wasn't it?
John Michelle, bro.
Oh shoot.
What?
Oh, it was
Why-
Newton.
Newton. Who's Levi? Are you bobblehead?
What is one factor?
It's the
Color.
height of a person.
You
It's the
missed
color,
the-
guys.
Like if you got
the-
like
What is
a
one
Because the
basketball player,
wavelengths
Duncan.
of
We
the
have to
light,
install grammar.
because the wavelengths of the light will affect your weight for sure. No, it's Mass.
Happy birthday.
Oh yeah, I'm in 4th place. I'm not off the leaderboard. What's happening on it? What's planet is called?
Oh, I
Maps.
wonder.
No, my mouse wasn't
Force.
working. I was halfway.
Shoot, I said it out loud. Hopefully none of
It's
you
the
heard
force,
that.
yo. It's just force. Force.
Oh,
Wait, Emma, how many
I was
different
wrong anyway,
Transformers?
guys.
How
I
many
clicked,
different
wait, what?
Transformers have names that end in Tron?
So is
I
it
actually don't know.
Sir
Probably
Sir
a lot.
Paul McCartney.
Paul
Sir Paul
McCartney.
McCartney.
It's Sir Paul.
George
Paul Paul McCartney.
Michael?
It's Paul McCartney, guys.
Paul McCartney.
Paul McCartney.
Paul McCartney.
Sir Paul McCartney to you.
It's Sir Paul McCartney. Also, how do you guys have 87,000 points?
I don't know.
Composition, location in the universe.
Composition and location in the universe.
I mean, technically, size and density isn't wrong.
Yeah. Mass and distance isn't wrong either.
Hey Emma, I have a question. Do you always leave your ceiling fan turned off?
Yeah, no,
Not
she
always.
never turns the ceiling fan on. She's never turned it on. It's
Does
just
it annoy
growing
you
dust
as
and
a
stuff.
ceiling fan enthusiast that I have my ceiling fan off? Bob.
Bob.
Gravity.
That are small and far apart.
Blue. It's blue.
Guys, the answer is Paul McCartney. Sir Paul McCartney.
No, it's Sir Wu.
I'm never gonna get over that.
I mean, how am I remaining in 5th place this long? This is
Yeah,
blasphemy.
how are you, Emma?
Fine, I have to leave.
Force of gravity between a planet and an object on its surface.
Oh shoot. Oh shoot. I don't think I got
Planet
this
in
one
a-
right, mates.
I got it wrong. I got it wrong. I got it wrong. Wow.
Oh, was it all of these?
Well, I mean,
It was all of
just the
these.
massive one.
I chose
It was all of these. I'm in 8th place. Let's
Oh,
go.
there we go.
Go
16.
on the leaderboard, yay.
There we go. Just as I predicted.
Matter.
Of
It's green. It's green.
yes,
7th
sir.
place. Okay.
Levi.
Yes, sir. Yes, sir.
Levi, where do you live?
Off her roof? Why is she on her roof?
Yeah, why is she on her roof?
It will be
Gravity
destroyed.
will not affect the book. It will be destroyed.
It will be destroyed.
West? Why west? West is not down.
How
Levi,
very
where do you
strict-
live?
It will make the book move
Wow.
west.
Yeah.
It'll make the
Book
book
will be destroyed.
Well, you know, actually, if you're counting air resistance,
Oh shoot.
it will decrease the speed.
I'm 19 points behind nickname.
Nobody causes all.
Who is nickname?
Cubes, it's cubes.
It's circles, guys.
It's
You
cubes, guys.
almost
It's
got me.
cubes. It's
You
cubes. It's
almost got me.
cubes.
Cubic
You
planet.
almost got me.
It is cubes.
This planet has the strongest gravity of all the planets.
Your mother.
The solar
In the-
system.
It's Earth, guys.
Wow.
It's
The
Earth.
sun. The sun.
We are
It's the sun.
superior.
It's the sun.
The sun isn't a
The sun's
planet.
not a planet, bro.
No, really.
Atmosphere.
See, we just learned about this, Miss Tara. It's the sun. It's not the moon.
It's true.
I don't like that. I don't like that.
Levi.
I don't like
Levi, I have
that.
a question. Have you ever broken Lola?
Excuse
Wow.
me?
The last time we talked about has Lola broken Levi, so I'm wondering if Levi's broken
He
Lola.
was his impeccable hearing skills.
It's Yellow.
Guys, y'all want to know what my avatar is? It's Elvis.
Elvis. Thank you
Yeah,
very, thank you very much.
I'm in 5th place.
I'm in
Yay,
6th
now I'm
place
in
and
third place.
I'm
I'm 1,070 points behind. Measures.
So
That's
I'm
how
sure.
you
How
are.
tall you are.
How tall
It's
you
how
are.
tall you are.
That's what acceleration is.
There's
Why
always
would
a
you
hole
skydive
in
It's
like that?
guys, it's how tall you are.
I'm in 6th place behind Galvatron.
I'm so glad
Yeah!
nobody picked how tall you are.
Oh shoot.
Multi-select.
multi-select.
What is acceleration?
Oh.
How fast you run?
How
from
fast
a
you
wo-
run from a wild bear.
It ain't wrong. Oh shoot, I think I left one out. I think I left one out.
It's
Oh,
not
no.
red. It's not red.
Oh,
I'm gonna go ahead and
no.
tell you.
Well, I mean,
How fast you run.
Is red.
I mean,
Dang
technically,
it. I got it
How?
wrong.
North.
Yeah.
Wait, what?
Or
No, I
nor.
selected
Wow.
all those.
Or
What?
nor.
No, not Leif.
Yeah, I selected all
kidding
those
me?
ones.
Left, 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 left.
None.
God,
It has to be.
God.
It's less because actually on
Green.
Mount Everest there is a slight change in gravity because of how far away from you
Yes.
are from.
I'm chasing Emma now. I'm chasing
Who has a streak of 18?
Levi.
Probably Levi.
Oh my gosh.
We
It's
reached
the
the
point of no return.
We reached the
Falling as fast as the
hopefully
air
we
is
reached for the
so
parachute.
low.
We reached the-
reached for the
The point of
parachute.
no return.
The point of no return.
That's
The point of no
crazy.
return. Parachute is funnier now.
Oh shoot,
The
Emma.
point of no return, guys.
Emma,
Who
I'm
chose
I'm
reach for the
ungaining on
parachute?
Emma.
Uh-oh.
It says that in the picture.
Guys, the answer is purple.
There is a
You know
purple.
purple in here?
Yeah, you have to click both of them at the same time.
That's not how it works.
That's not how.
It's possible. You gotta
Oh,
try,
shoot.
bro.
Wait, what?
Yo, I just popped my neck.
Equals RT.
I'm not correct yet, aren't I? Oh
Yay.
man, I am correct.
Nickname.
Yeah, somehow I'm still in
Nickname.
What equation is used to calculate
Scrabble.
how the moon traveled? The moon equation is used to calculate how far the moon traveled in one orbit around the Earth.
I got it. I think I
It's
got it
E
right.
equals MC squared. It's yellow,
Yeah, I
guys.
got it.
It's yellow.
Yep.
I'm behind Bob.
No, E equals
Hey, I'm in 8th place.
It was built around friction.
A domino chain.
A domino chain.
A domino chain. Like,
Absolutely zero
domino chain.
friction.
you know what else is a
Absolutely zero
domino
friction.
chain? Pizza.
I was just about to say that. I was thinking of down the nose.
Good one.
4th place. Oh my gosh.
Guys, you have to automatically go
Building
ahead
the
and
box.
assume that the most
box.
Building the
descriptive
box.
Leonardo da Vinci.
Wait a minute. Build a
Oh,
bear.
guys, like the box.
build
The
a
box.
Lego
Build a
house.
The box.
Da
It's a
Vinci. Oh
follow-up.
shoot.
Pick up
It
the
was Da
pieces
Vinci.
and build a Lego house.
Oh shoot. It was John
John
Michelle.
Mitchell.
It was build a box.
John
Build a
Mitchell.
box for treasure.
Build a bear.
The gravity.
Uh-oh, it's a math problem.
What? 270 oh my
What is
gosh.
this?
70 kilogram. What happens to the gravity of 270 kilogram people?
Miss Tara,
I
you
don't get
are
the
sick.
question. Miss Sarah, I don't get the question.
3
Hey,
meter.
that's my mama.
Here's the part. Walk in opposite directions to
like
increase.
But the amount of
Nothing
time that we have,
happens.
it's gonna be.
Y'all,
God.
nothing happens.
I don't get this.
This was in your reading.
It doesn't change.
This is Cap.
The
Instantly
weight
reach
doesn't
this-
matter.
Guys, it's flat out Cap. She's trying to make you
my
overthink
friends
it.
use Cap a lot, so I'm gonna start using it too. Like this is really Cap.
Cap.
I call Cap.
Huh?
Guys, she's trying to make you overthink it. Just select
Bro,
the
why
purple
is-
triangle and then we can all be done.
Why is 9F even an option?
Yeah,
What is
I don't.
F?
That's the
What is
fourth.
F?
9/2 means
Force,
it's
I
9
guess.
times the original.
9
It's there to
force.
trip you up.
Guys, she's trying to make you overthink it. It seriously is the purple triangle. That's what I picked.
No,
Me
it's
too.
1/9.
I guess.
It's 1/9 to 1/3. I'm
I
choosing
guess.
1/9.
Someone
No,
choose. Someone
she's
choose
trying
Pentagon.
to make you overthink it. This is
Someone
what's
choose
happening.
Pentagon.
Who's
And if I'm wrong,
not
I'm bringing you all down
answering?
with me.
Everyone
Just
just
No one.
answer.
I guess.
19.
Lord, if I'm
18,
right with guessing.
17,
Oh,
16.
Yeah, I guess it doesn't change.
if I'm right.
Yeah, guess it doesn't
Oh,
Sir,
change.
ask
Like,
me,
on
this is
point.
confusing.
I told you people,
Or will
she's
be
making
right
you
again.
overthink it.
If you wait till the last second to put your answer in.
I wasn't overthinking it. I'm guessing.
Who did the problem in the
Wait,
problem?
what?
Way!
Yeah!
No
I was
way.
right.
Four
No
people.
way.
No way.
No
Four
way.
people did this problem, example
I
problem.
win. I did it. How come I'm not in third place?
That's right.
Yeah, my screen is just gonna be a ceiling fan.
I signed.
The one question I actually know.
Oh no, you don't.
Wait. Oh, shoot. I just.
Why is
Guys,
there
it was
like a hole in the
Galileo.
oak?
I don't
Oh,
want to
wait,
Galileo
no.
was in
here. I don't
quantum
want to be
physics.
here. I want to be there. Okay. Yippee!
What?
Emma.
Who is Eva? Oh, unlike
In
it.
free fall, you feel weightless. True.
Actually, no, you feel fear.
I think
and
it's
you
more of
don't
an
feel-
opinion, if
It's
you will.
called going to a roller coaster
No.
place
You don't.
and
You
you
don't feel
experience it.
weightless. You feel fear. You don't have time to feel weightless.
Fear.
I mean, not really.
Really a force.
I don't really fear
Miss
falling.
Tara,
50
Stop trying to
50
trick us.
chance.
I don't know. This is.
Oh,
alright.
shoot.
Yay!
I'm behind Emma. I'm behind. Wait,
Yeah.
No,
who's-
I'm just
Uh-oh.
gonna start selecting what I think is the wrong answer because I've
Bro,
got no clue
multi-selects never
anymore.
work.
Happens when an object falls.
It falls.
I don't know. It hits
It goes
the
in a brief
ground.
free fall. Everything is in loop.
Everything in is illusion. Why does that remind me of the Bill Stepper? Everything in is illusion. Your reality is illusion. Buy gold. Bye.
My life is a lie. I mean, technically, according to some theories,
Don't go with the and technically don't do
Wahoo.
guys, according to some theories, we technically could be living in an illusion that is
Yeah.
just designed to help people solve their problems.
They
that. We
compliment
just
you.
like to think that because we like to
compliment
make
you.
ourselves
Not working.
scared.
Compliment you.
They compliment you.
They compliment you?
They don't
They
sink.
compliment
They
you.
compliment you.
They
They do not
compliment you.
sink.
I have an answer streak of
I am
2.
keeping 4th place right now. I don't know why. I don't know
The
how.
cosmic
Electric pole.
A big microwave. It's a big microwave.
A big microwave.
What else would it be?
Yo, I could cook a 10 million
Guys,
pound
it's a
turkey
big
in that.
Oh, someone
Who's
said
in a
green.
big
Come on.
microwave?
Who's ready for
Who
Thanksgiving?
seriously just said a big
What is
microwave?
Downchastic electrodynamic.
What is. Oh.
What's stoichiometry? Wait.
Stoichiometry.
Who seriously said just a big microwave? What else would it be?
Stoichiometry.
I want to know and give you a handshake.
It wasn't me.
I'm behind toes.
You're behind me. You're behind my toes, bro.
The 4 forces of nature:
Eat my
water,
toes.
sound.
Gravity,
Water
sound.
sound.
electromagnetism, and strong nuclear.
Water sound.
I don't like how long it took me to answer.
Gravity.
I chose that
It's
one.
earth, water,
Electric.
earth, water, fire, air.
Gravity.
Last one.
Oh,
How do y'all have 200,000 points?
Weakest.
200,000.
Almost.
Wait, no,
I'm
no,
gonna
I
get second
misclicked on the
place.
last question.
Yes, I will screenshot it.
yay.
Oh, I meant to click
An answer
gravity.
streak 18 chat?
Podium
Gravity,
award.
all lowercase.
Me am a guy.
I thought
Me
that
and
was
my
you,
guy.
Levi. Me and my guy.
Or they-
No, I'm bobblehead.
I'm
The
I don't
first
know who this was.
Who's Eva?
Eva.
Guys,
Snap
Eva
to
is
whoever
Eva.
it is.
Oh,
Eva. Oh, wait,
yippee! I
yes,
got
we have an
I
Eva.
got an honorary mention.
Oh, did you get the aim for the podium next time?
I got the
No, learning is believing.
I got the podium
Seeing
awards.
is
Seeing is
seeing is perception of light.
All right. Well, good job.
The 4 forces are consciousness, levitation, gravity, and
Yeah.
Blix.
You guys have
Miles,
special
why are you
sauce.
just showing your fan?
I don't know.
Gravity, levitation, consciousness, and Blix.
I just wanted to say something, guys.
You guys have solved the two-body problem.
For
meaning
everyone who didn't make it, aim for the
gravity
podium next time.
between two objects. What would the equation look like if they were three objects?
Oh god.
Why do you have a one?
Is that
Oh,
the Canada
no.
money
Oh,
I see?
I don't want to think about
Yeah,
it.
but Sarah,
you're-
who's getting that money?
Yes,
Who's
this
getting
is
that
my
money?
money.
Canada money I see?
No, that's my
That's
my
Canadian
favorite.
money. That's
It's
Canadian money.
toy money.
Canadian money is beautiful.
It really is.
Yeah.
Is she really bribing
Canadian
us?
money is prettier than US money.
Canadian
Like,
money isn't as
it's
beautiful
got like
as
a clear
USA money.
part in the
Yeah,
money.
it's got a
that's
clear
really-
disc to help prevent counterfeit. To help
Yeah,
prevent counterfeit.
really cool looking.
It's
Yeah,
more
but
beautiful than
you're-
the USA money.
Oh,
Oh yes. Oh yes.
USA
Yes.
money.
yeah.
Dude, USA money is just green paper.
But we just like green
Green
people.
paper.
Green paper.
So at any rate, you solved the two-body problem. Your parents might be watching. There's a recent show that just came on that I thought was hilarious. It went just with what we're doing. Is if
It's
you
the
had
body problem, right?
yeah, that right, the three-body problem, and
Yeah, I want
that
to watch
you could
it, but
on YouTube and see if anyone has been able to solve it. Because there are many instances where people cannot solve that. Where what is the attraction between and how are they actually going to move about and orbit each other? We've got the two. What if we introduce another mass to our equation?
Oh
We might
boy.
just
It all goes-
explode. We might just
It all
explode.
starts going wacko.
What about the
All right, good
Earth
job.
and the moon? We know how they
Riley,
work.
there is something I want to ask you.
Yes.
Riley, do you have any way you contact
Oh.
me?
Yes, let me do that because I know we were asking about playing games and stuff today. And
I already have
Shay
Emma's
has
number.
people-
give me a second.
of people
I need to grab my
contact.
laptop charger.
What about playing
Uh,
games?
Yeah, so if anybody wants to, like, they do Fortnite and Roblox and all sorts of games.
Minecraft?
outside.
I do Roblox.
I do
If
I
Minecraft.
don't do Minecraft.
And
Oh no, we
Minecraft.
used to have
Yeah,
a
some
huge
of them do
Minecraft server
Minecraft.
though.
I
Minecraft
don't
is
think I
best.
saw the in the Google Classroom, I think you can. Hey, Miles, can you stop recording and then we can
Yeah.